Let's take matrices A and B, two 2x2 matrices. A times B is written as shown. Okay, so straightforward so far. Now let's construct the resultant Z matrix. Z is going to be a 2x2 matrix. So to find Z11, we need to find the row and column combination that intersects it. Since this is an M times N or row times column matrix, we need to find the row, then the column reference. To do this, we go back to the multiplication sum and take the row featuring A11 from matrix 1 and the column featuring B11 from matrix 2. From this combination, we take A times W plus B times Y into cell Z11. Moving on to cell Z12, we are still on the same row as cell 11, so the row reference is unchanged. But we are one column over, so we use the column reference featuring X and Z. Z12 is therefore A times X plus B times Z. Z21 uses the second row and the first column references, while Z22 uses the second row and second column references. Let's put some figures into the equations. Multiplying out, followed by adding, gives us the resultant Z matrix from A times B. Let's see if there is any effect from switching the order of matrices A and B. On first glance, both row and column references have changed. Plugging in some figures will help us decipher the effect. Multiplying out, then adding, gives the resultant Z matrix. The differences in outcomes are clear to see when attempting multiplication, so we need to be mindful of the order at all times. Matrices do not always have to be 2x2 configured, but the number of rows of the first matrix should be equal to the number of columns in the second. Let's try multiplying a 2x3 and 3x2 matrix. So first we write the inputs, matrix A first, followed by B. The resultant Z matrix will be 2x2 as we have 2 rows and 2 columns to work with. For cell Z1, A, B and C are multiplied by U, W and Y. Cells Z12, Z21 and Z22 use corresponding rows and columns. Let's plug in some figures. Multiply out and add to reveal the resultant Z matrix. Switching to a B times A equation leads to a 3 times 3 resultant Z matrix. Let's follow the row versus column principle for Z11, then Z12, Z13, Z21, Z22, Z23, Z31, Z32, and lastly Z33. Now plug in some numbers, multiply out, and add to reveal our resultant Z matrix. To summarize, in this instance, switching the order and shape of the matrices not only changed the figures, it also changed the resultant matrix's size.